Okay, this is Mr. Long again, and this is our sixth video on stoichiometry. And the last video, we did the mass A to volume A. We had an example, and then we had one homework problem that I assigned you. So now, this is the sixth video, and we're going to go from mass A to volume B. So the first thing we want to know is, where is this on our roadmap that hopefully you have put down to memory by now. So we have mass A to moles A, and you're using the periodic table. Moles A of one substance, and use the coefficient ratio in the balanced equation to go to moles of another substance. Okay, and that, or moles B. And then we want to go to volume B using that magic number 22.4 liters of a gas in 1 mole of a gas at standard temperature and pressure, STP. So now feel free to pause me, rewind me, and look at this again, because I know I'm only giving you one example of each type of problem because there are a lot of different types of problems. So anyway, here is our example. Remember the S stands for solid, AQ is for aqueous or dissolved in water, and then G is for gas. So we can start with solid aluminum, and it's going to be mixed with aqueous hydrogen sulfate or sulfuric acid to produce aluminum sulfate plus hydrogen gas. So anyway, so our mole ratio, we've already balanced the equation, so you don't have to worry about that. 2 to 3 to 1 to 3. 2, 3, 1, 3. Now our question is, determine the volume of hydrogen gas produced at STP when a 2.00 gram piece of aluminum completely reacts. So we're going to use up that piece of aluminum. So in all our problems we start with what we're given. So we have 2.00 grams of aluminum, and whatever unit this is, if it's an apple up here, it has to be an apple down here. So we're going to put grams of aluminum. Now you want to know what is the molar mass of aluminum, and you look on your periodic table, it says 26.98. That we can round to 27.0. So we've got 27.0 grams of aluminum in 1 mole of aluminum. And so now we're on our first step, we're in moles of A. Now we've got to go to moles of B using the coefficient ratio from this balanced equation. So let's extend this and bring this down. So we have moles of aluminum, and we're asked to go to moles of hydrogen gas. So we've got moles of H2. Now you do not say 1 to 1. Okay, you look at our balanced equation. So by aluminum we have the coefficient of a 2. So that 2 goes right here. And in front of hydrogen you have a coefficient of a 3, and that goes right up there. So you're looking from moles A to moles B, you're looking at the balanced equation, at the mole ratio or the coefficient ratio. And we got one more step, we're going to volume of B. So we're going to draw this again. Okay, and we got moles of, we put a little m here, of hydrogen. And then we're going to go to liters of hydrogen gas. So in 1 mole of hydrogen gas, we have exactly 22.4 liters. So now we got to just look at this again. So we got mass to moles of A, and then we went from moles A to moles B, going to hydrogen, and then from moles B, going to volume of B. So we went through our roadmap here, and now let's go ahead and do the numbers here. All the ones drop out. Let's cancel out our units. That's my favorite part, making it simpler. Pull all the numbers over. So we got 2.00 times 3 times 22.4 and divided by 27.0 times 2. Okay. So now let's get out that calculator. And I've got this calculator right here, And okay, let's put this on clear. So we've got 2, we can drop out that 0.00 times 3, which is 6, times 22.4, which is 134.4, divided by 27, which is 4.9, and divided by 2, which is 2.4888. So 2.48, we're going to round these things to the 10th, so that's equal to 8 rounds up, you add 1 to the 4th, 2.5, and our units will be liters of hydrogen gas. So that's 2.5 liters of hydrogen right there. And I think that that would be good. So once again, we went from grams of aluminum to moles of aluminum, moles A, then to moles A to moles B going to hydrogen, and then we went from moles of hydrogen to volume of hydrogen at standard temperature and pressure using 22.4 liters. So we pulled all the numbers over, top numbers stay on the top, bottom on the bottom. It's like multiplying fractions. And then you multiply this out in your calculator. Let's round to the 10th, and there we go. Now, here's homework problem number 8, starting from the first stoichiometry video to this stoichiometry video. And, I'm sorry, starting from the mass video. So anyway, let's go ahead and write down this problem. What volume of ammonia could be produced by mixing 5.25 grams of hydrogen with unlimited nitrogen gas, or nitrogen. So to help you out, you're just going to write this. I want you to write this in your notes for your problem. And then using the same path, it's going to be exactly like what we just did. It'll be no different. So you'll be putting your grams of hydrogen here. You can go to moles of hydrogen, and then you're going to go convert from moles of hydrogen to moles of ammonia here, and then you're going to put in your 22.4 liters of ammonia in 1 mole of ammonia, and you'll get your answer. It's just like this one. Let's go ahead and do that, and then we'll go on to the next video.